Greetings, young geometers. In this video, we're going to be discussing segments and the segment addition postulate and midpoint. So lots of good stuff, lots of good notes. Make sure you follow along and write as I write. First off, measuring segments. How do we measure the distance between A and B? Well, first we got to discuss the distance between 2 points will be written as the length of AB, or we'll just write AB, and notice there's no bar above the AB. So AB written all on its own means the length of segment AB. Over on the side, really the easiest way is to just count hops, right? So there's 1, 2, 3, 4 hops. The length of that is 4. Or you can say AB is defined as the absolute value of the distance of the two locations. So -1 was where A was, B was at 3, and it's going to be the difference of those, the absolute value. So -1 minus 3 is -4, and the absolute value of -4 is equal to 4, or 4 units. Remember that these bars up and down, absolute value, mean the distance from 0 on the number line. Now, moving along to congruent segments. So we're looking over here, and we notice that they look like they are similar. So we count the hops, 1, 2, 3, 4, and 1, 2, 3, 4. And I notice that they are the same length. So I can say that AB, the length of AB, is equal to the length of segment CD. Right? Then the segments are congruent, right? And that basically means that they are the same measure. So go ahead and write that in your notes. This is written, right? If they are congruent, I'm going to write segment AB with the bar over it is congruent to segment CD. So notice that their lengths are equal, right? So when I say the length of AB, there's no bar up here. When I put the bar up, I'm saying segments. So segments can be congruent, right? They're twins. Their lengths can be equal. So that is congruent segments. Again, taking note that C is at -5 and D is at -1. So the absolute value of their difference is the distance. Absolute value of the difference is the distance. So that's -5 minus -1 is +1. And that's going to be the absolute value of -4, which is 4. So again, CD is equal to 4. AB was equal to 4. So AB, the length of AB is equal to the length of CD, which is both 4, making them again congruent segments. Down at the bottom here, segment addition postulate. Just so you know, postulate are what we refer to as house rules. So just kind of chuck that word somewhere in the space right here on your paper. And it's very simple, straightforward, just as you see. We're going to be talking about adding segments. And so what do we know? I know that if I take the length of AB and I add it to the length of BC, I'll get the length of the whole piece. And so we're just going to say it just like that. The length of segment AB added to the length of segment BC is equal to the length of segment AC. And so we're going to write stuff like this and draw some pictures often. So let's put this into practice. We're going to use this diagram over here on the right to answer the questions over here on the left, right? So we have some examples, and number 1 starts out with PQ equaling 9, the length of segment PQ, and the length of segment QR is equal to 28. So I see this diagram up here, but I want to sort of demonstrate some good geometry practice. So the first thing I would say was, well, let's see, they want me to find PR, so I'm going to draw my own segment. And I'm going to put some points here. Here's my P and my Q and my R. And now I want to label, right? Label the drawing. First, make a drawing, right? Make a picture, and then label it. So PQ is equal to 9. So I'm going to say, okay, you know what? This is equal to 9. And QR is equal to 28. And I need to find PR. So that is what I'm looking for. Well, obviously, that's that added up. But what I'm going to say is, well, PQ plus QR is equal to PR. That's the segment addition postulate, or SAP. Now what I do is I substitute what I know. So I know that PQ is equal to 9 plus QR is equal to 28 equals, right, that comes right down, and then PR drops down. That's what I'm looking for. So I don't know what PR is. So, okay, well, 9 and 28 is 37 is equal to PR. And there you are. The answer to this is 37. So it's just good notation and then good slow algebra movement. Okay, number 2. So what are we going to do for number 2? We're going to repeat the process. So I'm going to draw a segment P, Q, R, because it said to use it for questions 1 and 2. Put a dot at P, put a dot at Q, put a dot at R. And then I'm going to say, well, let's see here. QR is 17. PR is 21. That's the whole thing. Find the length of PQ. So this is what I'm looking for now, right? Well, again, I'm going to write the same segment addition postulate. PQ plus QR equals PR, right? The little guy, right? The little guy plus the little guy equals the big guy. And now I'm just going to substitute where they gave me the information. So I'm not always looking for PR. This isn't always going to be my unknown. Maybe QR is my unknown. Maybe PQ is my unknown. But the relationship looks like this. PQ plus QR equals the length of the whole thing. So substitute in what you know. Instead of PQ, what am I going to write? PQ is this. So I'm going to substitute in X plus QR is right here. So what am I going to write? 17 equals the big part. PR. What is PR? 21. Okay, and now you finish and you tell me what is the value of X. So you finish that problem. Now, immediately, the algebra looks a little bit crazier. It's okay. I see this whole piece right here and I say, oh, well, let's write the segment addition postulate, right? How does the segment addition postulate apply to number 3? EF, the length of EF, plus the length of FG is equal to the length of the whole thing, EG. Now what? Let's go figure out what they've given me. They've given me EF. EF is 8x minus 17. No problem. I'm going to substitute that in. So in for EF goes what I know about it, 8x minus 17. I'm going to add that to FG. FG is right here. That's 5x minus 3. So I'm going to write 5x minus 3 equals EG. What's the length of EG? Sorry about that alarm. EG is, they told me up here, 71. So I write 71. It's kind of an ugly 71. Now what? Now let's finish. All we need to do is find the value of X. So the answer to this question is X equals. Well, how do we do that? Next up is to combine like terms. This is why I said we need to practice a lot of algebra. So I got 8x and positive 5x gives us 13x. Negative 17 and a negative 3 is a negative 20 equals 71. I get x by itself, so first thing I'm going to do is move my constants over to the right side. Get 13x equals 91. Divide both sides by 13. And I'm just going to scooch my x over there. And I'm going to get an answer of x equals 7 as my final answer. Bada boom, bada bing, done. Now to check this answer, if you want to know if you're right, remember we said that this 8x minus 17 plus 5x minus 3 is equal to 71. Well, is it? We said x was 7, so 8 times 7 is 56 minus 17 plus 5 times 7 is 35 minus 3. And then 56 minus 17 gives me 39 plus 35 minus 3. And 39 plus 35 gives me 74 minus 3 gives me 71. Check. This is definitely right. Check plus, check plus, check plus. Now what? Welcome to geometry. Let's do it again. Let's move over to number 4. And what do I see? I see a different segment, but nonetheless, I can apply the segment addition postulate. So what do I know? I know that TU plus UV equals the length of TV. So TU plus UV equals TV. That's the first step, right? And this is the geometry. Next is the substitution, right? So I'm going to substitute. Instead of TU, I'm going to write what? 9x plus 2. Instead of UV, what am I going to write? 5. Instead of TV, what am I going to write? This whole thing. They said TV was equal to 14x minus 8. No problem. Now what? Let's combine like terms. So we got 9x, and then the 2 and the 5 go together. So that's going to be plus 7 equals 14x minus 8. Now let's get all of our x's to one side. So I like to move the 9x to keep the coefficient of x positive. 7 comes down, the 9x cancels. 14 minus 9 is 5x. Minus 8 comes right down because I didn't do anything. Add the 8, and we're going to get 15 equals 5x. All right, when I get 5 by itself, or x by itself, so we're going to divide by 5, and we're going to get x equals 3. All right, and notice I write 3 equals x. I said x equals 3, but I kept my x on the right because my x was on the right side. Now, am I done? No. They asked me to find the length of TU. TU was equal to 9x plus 2. That was this left side over here, T to U. So TU equals 9 times 3 plus 2. That's 27 plus 2. That's 29 is equal to TU. And there's my final answer. Now, if we were taking this on a quiz, I think this is a 4-point question. Where do you get the point? I'd say point number 1 is just for writing the segment addition postulate. Point number 2 would be to do all the algebra in a reasonable order. Point number 3 would be to get the algebra actually correct. And then point number 4 is getting your final answer, right? So if you stop short here on a 4-point question, I'd give you 75% of the credit. So showing your work is going to be critical. You're going to be confused early on. You're going to make some algebra mistakes. That's okay. Just keep asking questions. Okay, in the next 3 examples, I'm going to get you going in the right direction, and I'm going to have you wrap these up on your own. Number 5 comes with a segment, JL. The entire thing is JL. And then we have 2 little parts, JK, segment JK, and segment KL. So let's write the segment addition postulate as it applies. JK, the length of JK, plus the length of segment KL is equal to the long one, JL. And now we're going to substitute in known information. So instead of JK, we're going to write what JK is worth, 27, plus KL. Instead of writing what KL is, we're going to write what KL has been given to us, 3x minus 1, equals, what's JL worth? JL is worth 5x plus 2. So we're going to put 5x plus 2 right here. Find JL. So let's get to it. First thing we want to do is, we're now in the algebra portion, is we would like to combine like terms, right? So let's combine like terms. I know that positive 27 and negative 1 can go together. So 27 minus 1 is 26. Plus the 3x that I didn't touch equals 5x plus 2. All right, so I have x's on both sides. So I'm going to choose to subtract 3x from both sides. And the reason I subtract 3x and not 5x, I want to keep my coefficients positive, right? So I know that 5 minus 3 would give me a positive. So let's keep that the way it is. So let's see, the 26 is going to come down. 3x minus 3x goes to nothing. 5x minus 3x is 2x plus 2. Now, since I pushed my x's to the right, I'm going to push my constants to the left, and I'm going to get 24 is equal to 2x comes down, and the 2's cancel. Notice that I keep working from left to right, top to bottom, because that's how I read. So I'm just going to recopy that. That's 24 equals 2x, right? Just kind of brought that up from over here. Now I'm going to separate the 2 from the x, and I get 12 is equal to x. I'm not done. They asked me to, again, find JL. And JL was equal to 5x plus 2, and x is equal to 12. We just figured that out. So now we're going to say, all right, well, 5 times 12 is 60 plus 2. I guess JL is equal to 62. And that's our final answer. Now, just for the record, 3x minus 1 was the length of KL, and x was, again, 12, right? X was 12. So 3 times 12 is 36 minus 1 is 35, and this is 27. If I take 27 and 35 and add it up, I get 62, which is what I said the length of JL was. So here's our final answer, and I feel pretty good about that. We've checked it. Here's our value for x. Again, if this were a 4-point question, I think that this is worth 1 point. I think some decent looking algebra, even if you make a minor mistake, is worth 2 points. If you get it all right, you get 3 points for finding the value of x, and a 4th point for that answer there. All right, so let's look at number 6. Find the value of x. All you need to do is finish out with x is. So how does the segment addition postulate apply to this problem? I think if we took CD, right, this part here, and added that to DE, this part here, we should get the length of the whole thing, which is C all the way to E. All right, and now let's see what we have in terms of given information. It's been given to us that CD is worth x plus 3. DE is worth 8x minus 9, and CE has been given to us as 7x plus 4. So you finish, get a value for x, and then you're all done. Last problem here. Don't let the huge piece fool you. No big deal. We have segment addition postulate as it applies. So it looks like SK, that piece, the length of SK, added to KY, this little piece right over here, should be equal to the length of the whole thing, SY. And now let's start substituting in what we know. We know that SK, right, SK is worth 13x minus 5. No problem. We know that KY is equal to 2x plus 9. So that's going to go right here. And we know that SY is equal to 36 minus x. When we're done, we're going to have a value for x, right? And that's going to go right here. Then they want us to find these 3 lengths. How do we find them? By substituting in the value for x into each piece, right? And then this will be the length of SY. I'll put it right here. This will be the length of KY. I'll put it right here. And this will be the length of SK. I'll place that right there. All right. Again, I probably would move my x's to the left side when I'm done, because I would be able to add x to this side. Don't forget that before you get going too far in the algebra, that you will want to find, you want to combine like terms and get the left side nollied down a little bit. All right. So finish that up and you're good to go.